Every new model release brags about beating the last one. But who's actually grading those answers? Paying humans to read thousands of outputs is slow and expensive, so the industry quietly switched graders. Today, a strong model like GPT-4 sits in the judge's chair and scores everybody else. It powers leaderboards like MT-Bench and AlpacaEval, and it correlates surprisingly well with what people prefer. Here's how it works, and where it quietly lies to you. Look, to understand why anyone would trust a model to grade models, compare the two ways we can evaluate. Human evaluation is the gold standard. Real people read each answer and say which is better, so you get judgment that reflects genuine taste. But it's painfully slow and expensive, and it simply does not scale to the thousands of comparisons every new model release needs. Waiting on human annotators can stretch an evaluation from minutes into weeks. Using a strong model as the judge flips that. You hand it the outputs, it returns a verdict in seconds, and suddenly evaluation is fast, cheap, and scalable. Remarkably, these verdicts correlate surprisingly well with what humans would have chosen. The catch is that this judge carries hidden biases, and if you leave them unmanaged, your numbers quietly lie. Now, several things really matter once a model is doing the grading. Let's walk through the ones that decide whether your numbers are trustworthy. First, the whole appeal is scale. Automatic scoring lets you run huge evaluation sweeps for a fraction of the cost, which is exactly why benchmarks like MT-Bench and AlpacaEval lean on a judge model instead of a room full of annotators. Then come the biases you have to watch. Position bias means the judge tends to favor whichever answer it sees first. Verbosity bias means it rewards longer answers just for being longer. And self-preference means a judge quietly favors outputs that sound like its own writing. So you fight back with mitigations. Swap the order of the two answers and average the results to cancel position bias. Give the judge a clear rubric so it grades on substance. Prefer pairwise comparisons, and when it really matters, use a panel of different judges instead of one. None of these are exotic. They're just the discipline that keeps an automated grader honest. Here's the actual setup followed end to end. Everything starts with the candidate outputs. You collect the answers your models produced for a shared set of prompts, and those responses are the material the judge will weigh against each other. Keeping the prompt set fixed is what makes the comparison fair. At the center sits the judge model, handed a clear rubric. The rubric tells it what good actually means for this task, which keeps it grading on real quality instead of drifting toward whatever answer merely sounds confident or long. Then it produces a verdict. Usually that's a pairwise call. This answer beats that one, or a numeric score per response. Pairwise tends to be steadier because deciding a winner is easier than pinning an absolute number. Asking for a clean comparison also gives the judge far less room to drift. Finally, you aggregate with the debiasing baked in. Average across swapped orders, pool a panel if you used one, and roll everything into a leaderboard number you can actually trust rather than a single unchecked opinion. Alright, let's lock in the essentials worth taking with you. A strong model can grade other models' outputs, turning slow, costly human evaluation into something fast and scalable. This approach already powers real leaderboards like MT-Bench and AlpacaEval, and it tracks human preference closely. Watch the known biases carefully. Position, verbosity, and self-preference will inflate scores if you never control for them. Manage those biases by swapping order, writing a rubric, and comparing in pairs. Want more AI ideas unpacked without the jargon? That's the whole point of Standarity.com. Come say hi.